This video is taking a look at types of reactions. We have reactants, yield, products. Now as we go through and take a look at our types of reactions, we're going to be making generic equations to help us better recognize these reactions. So we're also going to be taking a look at A's, B's, X, and Y's. The A and B is going to represent our cation or the positive metals, while the X and Y is the anions, our negatives or our nonmetals. Our first type of reaction that we have is called a synthesis. This is where two different components become one compound. An example of this for a generic equation would simply be A plus X, two components becoming one compound, AX. The opposite of this is decomposition, where that one compound breaks apart into two or more pieces. So we'd have the AX breaking apart into A plus X. So these are the generic equations for synthesis and decomposition. They are opposites of each other. An example of these two would be water, where you have hydrogen gas reacting with the oxygen gas to form water. Two components becoming one. A plus X equals AX. The opposite would be that water breaking apart into hydrogen gas plus the oxygen gas. So for this one, you would have your one component breaking into multiple. Yes, you would have to go back through and balance these reactions once you have the components. This second one, the decomposition of water, is known as electrolysis. Our third type of reaction we have is single replacements. This is where you have a compound that has an extra piece that wants to switch into it and kicks the other ion out. And we have two options. One is a cation, one is an anion. The cation is where the metal or the positive part replaces. The anion is where the negative or the nonmetal replaces. So for the cation, you would have a compound here reacting with another cation. The cations switch places, and then the A would be left in the end. An example of this would be our silver nitrate. It's going to react with copper. Now in this reaction, I want to show you, because I only have one of my polyatomics, do not use or take out those parentheses. They are extra information you don't need. When I put these together, we end up with our copper reacting with the nitrate, and silver is left alone. Notice the positive pieces are singled out. For the anion, we will have your compound again, but this time we're going to react it with an anion. So the A will stay in the compound and X will be left by itself. An example would be my potassium fluoride. I'm going to react it with chlorine. And we end up with potassium chloride plus our fluorine. If you take a look, single compound, single element gives us a single reaction. And for this one, because the chlorine and fluorine are by themselves, they are the anions, so this would be a single anion replacement. Our next type is our double replacement. This is where we're going to have two compounds making two new compounds. So as we go through and we take a look at this one, you have your AX compound plus BY compound to give us a new compound and a new second compound. Nothing is left by itself. So for this, we can have sodium chloride plus we can put in cobalt fluoride And then we switch them. The sodium and fluorine go together, while the cobalt and the chlorine will go together. Notice 2 compounds gives 2 new ones. Now a special decomposition we have is neutralization. This is where an acid and a base react and it forms salt and water. So we can have hydrochloric acid. The main reason it's an acid is because it starts with that hydrogen. We're going to react it with sodium hydroxide. Main reason this is a base is because it's got hydroxide in it. Now, when we put them together, sodium combines with the chlorine to create our table salt, sodium chloride, and the pieces left over are the H2O. So we end up with water. The last type of reaction we have is combustion. For our combustion, you have a carbon compound, and it always reacts with oxygen, carbon to make carbon dioxide, and water. So again, carbon compound reacting with oxygen to make a carbon dioxide and water. So, taking a look here, I've got my CH4, my methane, reacting it with oxygen to create carbon dioxide plus the H2O, our water. So again, combustion is simply a carbon compound plus oxygen, the O2, to form carbon dioxide and our water. These ones, be careful, they can get a little tricky when you balance and you may have to double. Remember, in all balancing, you want the lowest possible ratio when it comes down to our compounds. So that includes those coefficients as well. I want to take a look at how to apply these to finding the types of reactions on a homework.